Hello friends, we'll be talking about Heron's formula in this session. So let's first take a recap of the standard formula for finding the area of a triangle. Now we know from previous classes that the standard formula is area is equal to half into base into height. This is the standard formula that we've been using for finding the area of a triangle. So friends, now let's see how do we use the standard formula for finding the area of triangle. Now if we have a right angled triangle, let's draw a right angled triangle. And we have this as the base, this is the perpendicular and this is the hypotenuse. Supposing perpendicular and base are given to us, we can directly use the formula which is half into base into height, which is perpendicular in this case. So this is fine. So this is the simple way of finding the area of the right angle triangle. Now supposing the perpendicular is not given to us. Now then we use the Pythagoras theorem, which says that hypotenuse square is equal to perpendicular square plus base square. So we can find out P using the formula h square minus b square whole square root. So we can find out the perpendicular and we know the base, so we can find out the area of the right angle triangle still using the standard formula. For an equilateral triangle, so let's draw an equilateral triangle here. Now in this case also, now we know the side of the equilateral triangle is A. So we know that if from the vertex we drop a perpendicular on the base, we can again say that this perpendicular will divide the base into half. So these sides will become a by 2, a by 2. And now again we can find out the height using the formula a square, which is the hypotenuse of this right angled triangle, which is ADC. So we can say h is equal to a square minus a square by 4 whole square root. So we get this equal to the height is root 3 by 2 a. So now if we simply use the formula area is equal to half into base into height, we know half into base is a into the height is root 3 by 2a. So in this case also we simply get the formula root 3 by 4 a square for an equilateral triangle. So it becomes easy for us to find out the area of an equilateral triangle using the standard formula, which is half into base into height. Now supposing we have an isosceles triangle, again it is not very difficult to find out the perpendicular. So let's draw an isosceles triangle. Now this is an isosceles triangle named ABC, and we drop a perpendicular from A to BC. So we know that the equal sides of the isosceles triangle are A and the base is B. So we again know that the perpendicular from the vertex will divide the base B into half. So this is also divided into half. So we get B by 2, B by 2. So again using this formula we name this point D. Again using the Pythagoras theorem we can say height comes out to be a square minus b square by 4 whole square root. So now if we want to use the formula which is half into base, which is b, into the height, we can directly put the value of height, which is a square minus b square by 4 square root. So now you just by knowing a and b, we are able to find out the area of an isosceles triangle also using the standard formula for area. But what do we do for a scalene triangle? For scalene triangles where the three sides are of unequal lengths and all the angles are unequal, say for example we take the sides to be A, B and C. Now here we know that if we drop a perpendicular from the vertex to the base, we have no idea how this base is going to get divided and how do we use the formula of half into base into height. Now that is where the Heron's formula becomes very handy. Heron's formula, which is also called Hero's formula, was given by Heron of Alexandria, and this formula is used to find the area of the triangle when the three sides of a triangle are given. So let's see what this formula states. Now according to the Heron's formula, area of the triangle is given by this formula. A is equal to square root of s into s minus a into s minus b into s minus c. Now we need to know what are s, a, b and c. Now a, b and c are the three sides of the triangle and s is the semi-perimeter of the triangle and it is given by a plus b plus c by 2. So semi-perimeter means half of the perimeter, and perimeter is simply the sum of the three sides, which is a plus b plus c. So s becomes equal to a plus b plus c by 2, and this is the formula for finding area of a triangle knowing the three sides. So friends, now let's understand what is the application of Heron's formula. Now Heron's formula is used to find the area of triangle when its sides are given. Now this is just the direct usage, but the indirect usage of this is that it can further be used to find other parameters like radius of the incircle and circumcircle within this of this triangle. Now and there are many other cases where this formula is used. It is also used to find the area of a quadrilateral under certain conditions. Now if the sides of the quadrilateral and a diagonal is given, then we can directly divide this quadrilateral into two triangles using the diagonal whose value is given, and then we can use the Heron's formula to find the area of the quadrilateral. If one angle of the quadrilateral is 90 degrees, say for example we have something like this, then and its sides are given, then we know that using Pythagoras theorem we can find out this diagonal, and if we find out this diagonal, all the sides are given, we can find out the area of the quadrilateral. If the quadrilateral is a special case like a rhombus or a square and we know its perimeter, which would mean that we know all the sides of this quadrilateral and a diagonal is given, then we can find out its area. And there are many other cases where we can again use the Heron's formula to find out the area and in turn find other parameters. Friends, I hope you enjoyed the session. If you find it useful, please like it and share it with your friends. You can visit us at our Cool Smart Learning website and post your queries there. And please subscribe to the Cool Smart Learning channel for getting updates on the new sessions. Thank you.